So here's a simple example where we're given a network and they're asking us to solve for the mesh currents. They've already defined them for us, 3 different loops here. So let's apply that and see how we would solve for that. So the first one we want to look at is this loop here that involves this I1. So we'll designate that as that's for that loop. And so when we look at that, we see that we have this 30 ohm resistor. And so the 30 ohm resistor will have I1 going through in one direction and then I3 going through the other direction. So that being the case, we can write that then as 30 times I1 minus I3. And so then as we come around, we see we have this 40 ohm resistor. Same thing, we've got I1 going in the plus direction and then this I2 mesh current working against us. So then we can write this as 40 times I1 minus I2. And then that's all the components. We do have, worth noting, we do have this 20 ohm resistor and this voltage source, but they're in parallel, and we're calculating voltages. So the 20 ohm resistor really doesn't matter because the voltage across it will always be whatever that voltage source is. So therefore, we really only have to account for the voltage source. And all the voltages in here are going to have to equal to whatever that voltage source is. So we can write it as 8 IY just on the right-hand side. So that's everything involved with I1. Next, we're going to look at this loop here, which involves I2. And first thing we see is we have the 40 ohm resistor. So as before, it's going to be 40 ohms. And that's going to be times our I2, but then remember I1's working against us through that same resistor. So we have to account for that. And then next, we see we have this 50 ohm resistor here. And so we can account for that one. So that's going to be 50. And again, that's going to be I2 working for us, but I3 is working against us through that same resistor. It's going through in the opposite direction. I3. And so then finally, we have this 70 ohm resistor, and I2 is the only current that goes through that one. So it's in a non-shared part of the loop. So then that'll just be plus 70 times I2. And as before, we have this voltage source. Let's do that in a different color. This voltage source here. And so again, we're summing the voltages in our loops, in these mesh loops. And so again, the voltage here, because it's going in the same direction as our current, so all the voltage drops should be equal to that one voltage source. So we can write that as equal to 6 IX. So that's our equation for loop 2. And so finally, we've got this mesh current defined here, which defines that loop. So we'll do that one here. And so when we go down and look at this one, we already have the 30 amp in blue, so we'll keep that the same. So that's going to be 30 times I3. Remember, I1's working against us now, so it's going to be minus I1. Then we have the one in purple. So we can keep that one. So that's the 50 ohm. So that's going to be 50. That's going to be I3. But now the I2 is working against us. So it goes like that. And so the only real new one that we have is the 60 ohm, and we'll do that one in red. So the 60 ohm resistor right here. And so that one is simply going to be, because it's in a non-shared part, so that's going to be 60 times I3. And so again, we have the voltage source. This time the voltage source, because of where the positive sign is, we can see it's working against our current. So that's this 50 ohm, 50 volts, 50 volt source here. We see it's working against us. So then that's going to be a negative 50. So here's our three equations. We also have some supplementary things that we need to take into account. One is, and we'll do it in the same color, is this IX. That's the current going through the 30 ohm resistor. So IX, we can see, is just going to be equal to I1 minus I3. So we'll need to keep that in mind. And then the other current, which is going through this 50 ohm in purple, so we'll keep it purple, this IY is going to be equal to I3 minus I2. So that's the two mesh currents going through that branch. So now we should be able to take this IX and substitute it in here. And then our IY, we should be able to substitute it into here. And so when we make that substitution and we multiply things out and combine like terms, we can come up with our reduced set of equations. When we do that, we'll have 70 I1 minus 32 I2 and minus 38 I3, and this should all equal to 0. The next equation for the blue mesh or I2 loop, we should get minus 46 I1 plus 160 I2, and then minus 44 I3, and that should equal to 0. And then finally for our I3 loop, this one should reduce down to minus 30 I1 minus 50 I2 plus 140 I3, and that should equal to negative 50. So now we have our three equations and our three unknowns. We can write this in matrix form if you like. That'd be 70 minus 46 minus 30 minus 32, 160 minus 50 minus 38 minus 44 and 140. So that's our coefficient matrix. Again, that's multiplied times I1, I2, and I3. But you can solve this any way you want, but I think the most common approach is to use linear algebra and matrix analysis. So here, so in this case, you just divide this into there. And when we do that, we should come up with I1 is equal to negative 0.4180. I2 would be equal to negative 0.2695. And then I3 is going to be equal to negative 0.5430. So this is what they asked us for, is to solve for these mesh currents. And that's their values. You'll notice that they're all negative, which that means they're all flowing in the opposite direction of the direction we assumed. So we assumed they were all going clockwise, but the reality is the mesh currents are all going counterclockwise. So just something to note there. But this is the solution.